Hello everyone, Łukasz here. As Agata said, I'm going to present the topic of OpenTelemetry plus Mesmer plus Scala, a very interesting fusion in my opinion. I hope you will share the same opinion after this presentation. I work at Scala, as Agata already said, and I would like to thank Scala for having me here. I would like to thank Zyverge for organizing this great event. And yeah, without further ado, let me start my presentation. And I usually start with an example, but this example is going to be quite generic. What you see on the slide is some kind of a system. It has a front-end application that is written in JavaScript. It has two services in the backend, two instances of the services written in Java. But at some point, our developers decided to write something in Scala, just for the kicks, right? I'm just kidding. Maybe they wanted to migrate from Java. I don't know. But the case is that right now we have one service in Scala and one instance in Scala and two instances in Java. And since we are doing some data processing and we've got data engineers, we've got two instances in Python. At some point in time, we started asking questions. The first and the most important question is our product available, or are we losing money because it's not working? The other question, probably also very important, how many HTTP requests can we handle in the Java application? And maybe let's compare it with the Scala application, because it maybe shares some functionality, but does it better. What about the SQL queries? When we were rewriting our SQL queries from some Java framework, Hibernate or whatever, and moved it to, I don't know, some super cool Scala library, did the performance increase, or maybe it's worse for some reason? There's also an important question on what are the actual steps our requests take. Do they go through the Java service? Do they go through the Scala service? Or do they even reach the Python service? Or do they stop in Scala and go back to the front end with the response? So that's also useful to know. And of course, where can I see every log in one place? Do I need to, go to every console window while debugging, or do I have it in one place? So the answers to this question are metrics, traces, and logs, obviously. And this is all called telemetry data signals in OpenTelemetry. Most specifically, we have a metric for HTTP request throughput and rate. SQL query execution time is also a metric. For the request execution path, so the steps that my system takes, we should use tracing, and to collect logs in one place, we should have some kind of a log collection platform. I don't know, some kind of a Logstash, any tool you want. But the key thing is that it should stay in one place. So telemetry data sounds like a good idea. So okay, let's proceed with that. And to actually collect telemetry data, we need to send it over to some storage that will store that telemetry data. Simple as that, right? So we have metric storages, tracing storages, and log storages. And when we look at that, and when we think about multiple problems, there's a few that I can list right now. So the first problem is that if we have three types of signals, so metrics, tracing, and logs, and we have multiple languages, so JavaScript, Java, Scala, and Python, then there's lots of APIs. Probably every kind of signal has a different API, and we have to, or APIs and SDKs, right? And we have to write the code in multiple languages and for multiple signals. So that's a problem. Like a Cartesian product of APIs and SDKs to learn. The other thing is that when we use a particular API, we get vendor locked. So when we use Prometheus API, but then decide to migrate to something, I don't know, newer, or maybe move some metrics to some different system, then we need to use a different API. So that's another effort that we need to do. What about configuration? Does it always look the same? Is it standardized? Do the default values look always the same for different systems, or are they different? Do we need to, go through the configuration and assure ourselves that this is what we want, or do we have some kind of a sensible defaults? Also a problem to me. How do we correlate different signals? So how do we correlate traces and metrics? How do we probably need to write some custom code to do that. And that's only on the system side, on the left side of the arrow, because on the right side, actually in the middle, when we are sending the data, we have another set of problems. For instance, sending the telemetry data. If we have 3 signals and we've got lots of metrics, lots of traces and logs, then that's probably a big traffic. So do we want to send that directly and have lots of data flying over our internal network, or do we want to have a middleman that will probably aggregate the data in the middle and send it in some kind of a batches? Do we need to scale that middleman that will be there? Does that middleman need to do some additional transformations? And so on and so on. You probably get the idea. There's lots of problems, and we need some mitigation for that problem. So there's OpenTelemetry. And OpenTelemetry is a standard specification designed to mitigate this kind of a problem. It's not only the specification, to be more precise, it's the specification, APIs, SDKs, and lots of tools like the exporters and collectors. So it all started with the fusion of OpenCensus and the other product that I forgot the name. Yeah, thank you. So they merged and they decided to have the whole repository of standards written in YAML that everybody should relate to when they are starting their new language API or SDK, right? So those APIs are in different languages, but they're super similar. And for the different signals, they are also the same APIs. It's not like you've got separate APIs for tracing, metrics, and logging. The standards are there. The same goes for configuration and sensible defaults. This is all designed by OpenTelemetry, and every API and SDK has to adhere to that. Same goes for exporters. They use standard OTLP protocol, but they can also understand the native protocols. And there's also a great tool that is called the collector, that is the middleman that I mentioned to you. So it's like you get out of the box a tool that is going to offload your traffic and do some other great stuff for you, some transformations, some batching and whatnot. So already a great tool. And the telemetry backends are able to communicate with either the collector, so the middleman that I told you about, or the exporters when you decide to communicate directly. So this is how it typically looks like from the bird's eye view. You typically have the API, the SDK imported in your application in some way. You write some code in it. And when you run your application, there's also the exporter piece that is imported to your application, and that exporter gets all the data about telemetry and sends it over either using the OpenTelemetry protocol to the collector, for example, or directly, and this is not on the diagram, but you could technically go directly from the front-end application to the metrics backend, right? And what is important, that the OpenTelemetry protocol is translated to platform-specific protocols for you. So you don't really need to worry about vendor locking in that case, and different APIs and all the problems that I mentioned. That's the code that you would write when you decide to instrument your application manually, because that's what we're actually doing right now, right? We are adding instrumentations for metrics here to count my fancy feature usage, and the only thing that I need to do is that I need to build my counters, add some description, that's actually optional, but why not, and add some attributes and run the counter, and while we do that, OpenTelemetry will do everything for us. Of course, we need to import and start the pieces in Docker Compose, such as the collector that I mentioned and Prometheus. And when I run my example application, I get the metric in Prometheus. So that's manual instrumentation, and it's that easy in OpenTelemetry. So that's the starter. That's not all, of course. We've got the standard. It's already great because I don't need to worry about multiple APIs. I have one tool that is standardized, that can correlate, that can be configured in the same way. It's got a really nice and simple API. I just write code once, send data anywhere I want. But do I need to write the code myself? And no. OpenTelemetry takes care about that as well. So what I showed you was manual instrumentation, so manually writing code and letting OpenTelemetry to send that data. But there's also auto-instrumentation that uses a Java agent, at least in the JVM, that can be started with your application, and that Java agent will attach bytecode with similar metrics code or similar tracing code, and this way you won't need to write even a line of code to collect metrics, which is great in my opinion. This is how you run the Java agent, and yeah, when you run it, you see that it loads some instrumentations. The only thing that I needed to do is use the OpenTelemetry Java agent provided by OpenTelemetry, and it loads the instrumentations for us. And with no effort, I got traces and metrics that are provided for some libraries that I had on my class path. In case of my example, I had Akka HTTP, so I see traces for Akka HTTP. And I was doing a JDBC query. I don't remember even what library was that, but OpenTelemetry instruments tracing for JDBC, so I also see the execution time of the JDBC query. And that's only because I added the agent, so that's actually pretty nice. But that's not all. There's an example of JVM memory usage metric that is also added for you out of the box. And I don't even remember which instrumentation was that in OpenTelemetry, but I just got it for free, so great. So great stuff. We get a lot of metrics, but there's lots of support for Java libraries. I forgot to mention that, but what about Scala? Well, there's not so many libraries that are supported for Scala. There's actually Akka HTTP, and some little instrumentations for other Akka aspects. So what should we do when we write Scala and want to use OpenTelemetry? You can write an extension to the OpenTelemetry agent. And that's actually quite easy. You just need to implement something that is called instrumentation module that will have a name. And while you implement that, you have to also implement the type instrumentations method and send your byte body transformations, so that all the fancy things that will, modify the bytecode for you. And once you do that, you need to package it in a jar and pass it via the OpenTelemetry Java agent extensions parameter, right? And when you do that, you will get the instrumentation loaded alongside all the instrumentations that the OpenTelemetry agent provides. So that's pretty great, and this is what we are doing in Mesmer. It's an open source project. made by Scala, and it's nothing different than an OpenTelemetry agent extension set. Right now, it's one extension, but actually I'm quite not sure whether it should be, multiple extension jars or one big extension jar. And the nice thing that I will highlight multiple times is that it works together with existing OpenTelemetry instrumentations. So you get all those fancy traces, but you also get our Scala metrics that we carefully tried to provide for you. We're instrumenting Scala libraries and currently focusing on metrics. This is how you run Mesmer. It's exactly the same thing, but right now it's Mesmer OpenTelemetry extension over here in the Java extensions parameter, right? And the metrics we cover right now are Akka and Zio. For Akka, we've got a whole set of new metrics, such as metrics for Akka actor, Akka cluster, Akka persistence, and Akka streaming. So metrics such as, created, terminated actors, for how big the mailbox size is, and all the things like this. For cluster, how many nodes are there, are they reachable, unreachable, Akka persistence and streaming, also lots of examples. Maybe I shouldn't, go on with the examples. Maybe go check it out yourself under the link that I provided on the slide. It's easily to be found on the Mesmer repository, by the way. And for the Zio metrics, we actually wrapped the Zio metrics API. I don't know if you are aware, but Zio has its own internal metric API. It's an aspect. So it didn't really make sense for us to, to attach bytecode to add some custom metrics, because Zio already collects a lot of the metrics. Thank you. When it comes to wrapping existing Zio metrics, we focused currently on gauges and counters. We wrapped Zio gauge code and Zio counter code with our bytecode to provide the OpenTelemetry instrument alongside. And this way, we have all the Zio gauges and all the Zio counters that you have in your application in our OpenTelemetry instruments. And since the Zio execution metrics are not using the Zio metrics API yet, we did some manual instrumentation on our own, but that probably will change a little bit later. And again, examples, persistent event average time metric that we get from Akka, and Zio JVM thread state that you can get when you provide special layers to your Zio application, the default JVM metrics. But those are not the only examples. Apologies for not preparing the list of all the Zio metrics, but you can easily find it on the Zio repository, which ones are there, and we simply forward them. So you should expect them to be there as well when you run everything successfully. But that's just a screenshot of a list of metrics that it's like you should see the bar on the right. It's a long list. So that's nice for us. But we're not going to stand here and think that our project is finished, of course. We had lots of experiments, so I need to clean up that code base because it's a mess right now. But I'm going to do that. And we have plans to focus more on Zio. And after this event, I see that there's lots of potential in instrumenting Zio streams. That would be awesome to have, not only in Zio, but also on our side, so that you could just, plug and play OpenTelemetry metrics. And more Scala libraries. I'm a little bit, I don't really know where to start because there's so many of them. So if you go to our repository and go to the discussions panel, feel free to, send suggestions here if you want to have your metrics or traces maybe instrumented the way I just presented. And yeah, tracing is a big topic. I know that there's some tracing in Zio, but it's actually easier for us to work with metrics right now. I don't really know how to instrument tracing yet, but this is also on the list. And this is certainly doable the same way as we did with metrics, because the standard OpenTelemetry API that works the same way for tracing. So great stuff, great plans, great links that you should visit. Thank you very much. And do you have any questions? Please.
Hi, thank you for your talk. Can you use both manual and automatic instrumentation?
Yeah. I can repeat. The question was, can you use both manual and automatic instrumentation? Right. So, of course, you can do that. You probably should do that, because sometimes when you get metrics from libraries, that's probably not enough. But nothing stops you to add the code, and it will be collected by the same setup that you have for the automatical instrumentation, right? The only thing that's different is that the automatical instrumentation mechanism is just attaching the same code, but with bytecode manipulation. So
I have a couple of more questions, if you don't mind.
Go, please.
How do you configure automatic instrumentation? Like, if I don't want so many metrics, or I don't want traces for GDBC, for example?
Mm-hmm. Yeah, so there's a standard way of turning them off. You just pass the parameter, or you can pass an environment variable, or I think you can use configuration files for OpenTelemetry. But this is all OpenTelemetry stuff, and the beautiful thing is that we don't even need to worry about that, because even the instrumentation module that I showed you, when I passed the name in the constructor of it, you probably remember that, then OpenTelemetry will take care of all the standardization. So you can also turn off our metrics the same way as you would when turning off the metrics provided by the agent itself.
And as I understand, Mesmer doesn't support tracing yet, right?
Doesn't support tracing yet. Yeah. It's in a relatively early stage, so
waiting for it. Thank you.
Thank you.
Thank you very much, Łukasz, for your presentation.
Thank you.